Alright, so this is going to be about OpenShift, Docker, Kubernetes, all that kind of cool stuff. Big thank you to all of our sponsors and to the organizers of BSidesKC. So I'll start out with a little caveat. Abstraction is selective ignorance. So you need to be conscious about why you're abstracting something, and that you're not going to be able to, you shouldn't necessarily understand that piece. Someone in your company probably should, but just like we deploy to AWS, we probably don't understand all the underlying systems of AWS. So this is my conception of a data center. It's a little abstracted, but here we have in dev, we have RHEL 6.9. That's probably because I, as a developer, was troubleshooting something and ran yum update and updated everything. And then test is 6.8, so a little bit older, because we're a little bit more cautious and fewer mistakes end up in that environment. And then production is, maybe 6.6, because God forbid anybody ever touches production. And then at some point, I'm working on an application where I need access to production data, and so we provision a box that I have access to that has production data so we can go and demo to clients or something. And then that one ends up being 6.7 for who knows what reason. That was just what was in the template at the time. So then we create a new app, and that one is the latest version in development. And then we create 6.8 so that I can troubleshoot the problems that are in test. And then 6.4 because, somebody hit the wrong button. 6.7, now I can test the demo. Then we have Ubuntu, it's probably an acquisition or something. And then we have RHEL 6.6 so we can finally test prod. Because everything broke when it hit prod finally. Probably some HA proxy config change or something in RHEL. So we then have to add another admin, and then of course I've sold this now, all these apps I'm building, I've sold them to a client from dev somehow, and they start moving into test, and then we need to add another admin, and another, and another, and another, as I push it into prod with admins kicking and screaming saying, please don't do this. And then, let's go to the next slide. Oh, we had one disappear. Let's spin that up. Here's Ubuntu. Someone must have misnamed the template. I'm sure that's never happened to anybody. Alright, so that's a complicated mess, and it's usually that the large blob doesn't move up the same to every environment. It would probably be spun up with the newest stuff, which is somehow a different version than development. So the newer data center that I'd like to have is where you have a platform abstracting away your compute, storage, and network. And then you have a deployment pipeline that delivers your artifacts across all of the environments. So if you're spinning up a new application, it'll be RHEL 6.9 and your app will be deployed with it. It's going to be done with containers or VMs. You use tools like Chef or Ansible, or you can build Docker containers or images. So then you can deploy that image into test, and then maybe you have a second environment or third environment in your developer access only area, which should be a thing that every company has. And then a completely separate production controlled area where developers don't have access to any of that. So you can take the same artifact, deploy it up there, maybe you have a UAT environment, and then you have a couple instances in prod. And then when you come and you do a second application, you can use the same base image of RHEL 6.9, build the second app, layer it on top, and then you can spin up a couple for test, and then maybe you have 3 in prod. But it's the exact same image every time. So, how many people here know or have used Docker? A lot of people? All right. Excellent. So I'm going to go really fast over this. So in the early days, I started in like 2013. It was really awful. It was RHEL 6. There was kernel panics constantly. Docker is an abstraction, so it's really just C groups and namespaces. I assume everybody knows that. What wasn't included was metadata. volumes, secrets, we had services, and the network. So I used host network pretty much every time because it was so complicated and it wasn't very fast. Volumes were a mess. You just kept filling up your hard drive. And now you have a volume abstraction, so you can handle them as first-class citizens. You have secrets, and these are, so I'll talk about another secret here in a minute, but these secrets are actually encrypted, and they're kept in temp, so they're always in memory. So they're encrypted in flight and encrypted at rest. And you have network abstractions, lots of different overlays these days. And you have plugins, which a lot of these use to integrate so that you can swap in and out all the different components. And services, which abstract away the individual containers. And labels help you select on all of these. So you can say, I want the thing that has these labels on it. So this is an easy way to understand what an image is and what a container is. It used to be a much more complicated topic, but now I think everybody understands that the container is the writable piece of the image, and the image is below it. And that all rests on the kernel. And this kind of shows the namespaces right there, C groups, and SE Linux. That's something that traditionally we just turn to permissive because it's complicated and hard, and it is, and you end up locking yourself out of files, or at least I do. If anybody can actually understand it and operate it, that would be helpful to explain to me sometime. But OpenShift really helps out with this because it's on automatically and it just manages the whole thing. So who here is familiar with Kubernetes or has used Kubernetes? Mesos, Docker Swarm, any of those? Cool. All right, I'll go a little bit slower here. So Kubernetes also has secrets. These are bad secrets. Don't ever use these, or not until they fix it. So these aren't encrypted; they're just encoded, and they're stored in etcd. So, and they've also land on disks sometimes. I mean, these are not secure. They're basically environment variables that they turn into secrets and call them something different. So, but there is work fixing them right now. Then there's persistent volumes, which is similar to the volumes in Docker, but these are a slightly different abstraction. And then there's services, and so services in Kubernetes are based on abstracting away pods. So instead of having the individual containers, you now have groupings of containers, and that grouping that's called a pod guarantees that they're on the same node. And you also have now in Kubernetes, this is pretty recent, you have what's called ingress, which is the way traffic comes into the cluster from outside. So you can also call from inside of a cluster into an ingress, but then it has to leave and go through whatever HA proxy or F5 you have. You have daemon sets. These are basically your agents that you run on all the nodes these days, except for you can have them run inside of Kubernetes, and it ensures that either one instance is running on every node, or that one instance is running on every node based off the label set you gave it. So you can base it off labels. So for example, if we are running Gluster, we can run Gluster and name the nodes Gluster with a label, and then it will only run on those nodes. And a replica set is also used to be called a replication controller. Naming is hard, and Kubernetes you'll find a lot of different names in its history. So replica sets is just maintaining a certain number of pods. So if you have 3 pods that you want, and there are only 2 pods in the environment, it will create another pod. And then if a 4th one turns up because of a network segmentation, it'll kill one. And then you have deployments, which is kind of an aggregation of a lot of these. So it's just a document that you can write that will then deploy your replica set, your daemon set, and all the different component services. And this is the Kubernetes architecture. So it kind of shows you have your kube control is your actual command. Then you have your master, which runs your API, and it has some scheduler processes, replication controllers. It's actually a lot of different controllers. If you want to go see a really good deep dive in this, there was a DevOpsKC meetup earlier this week, and that should be on YouTube soon. If it's not, pester Aaron Blank. So then you have your distributed storage. You have on your node, you have your kubelet, you have a proxy, and then you have your Docker daemon with a couple of pods. All right, who here has worked with OpenShift? Awesome. All right, so in OpenShift, again, naming is hard. So they created routes, and then they kind of upstream those into Kubernetes as ingress for some reason. And so routes has more features than ingress. So it's a little complicated right now, but in OpenShift you can use either one. They did the same thing with deployment config and deployments. So deployment config came from OpenShift, they upstreamed it, they called it deployments, and now we have a confusing mess. So you can use either one in OpenShift. They also have image streams. I'll talk about this a little bit more later, but this one is pretty significant. And build config. So because OpenShift is a PaaS and Kubernetes really isn't, this kind of helps describe how your application would be built and deployed. And this is an architecture of OpenShift. So you have the developer operations all going through these same systems. And then you have on the top your routing layer, which is your routes, ingress, your service layer, which is your service, and then your underlying infrastructure there. And then you have persistent storage. And then of course all your nodes with the pods. So there's some particular security aspects that are important to know, and that is Linux kernel capabilities. And so originally Docker was pretty wide open. Their default was that you just had everything. It was basically root. So if you wanted root, you convinced some sysadmin to put Docker on your host, and now you have root. So right now they have pretty specific privileges, but there is I think it's called sysadmin capability, which has like a catch-all. So you end up, because I don't remember, there was 32 or something based off of that's as many as we ever thought we would have, and now they've just kept filling up the last one. So what Docker has done is they've figured out that there's certain defaults that you should have. So for example, if you're going to spin up a container that wants to listen on port 80, and they just give you the capability to make a network connection for port 80. And the problem with these is that they aren't quite granular enough. So like I was saying, that there's like kind of a catch-all one, that if you restrict that, you kind of have to allow it to be open, because if you restrict it, then you can't do much of anything. It's still an improvement, but even better is SecComp security profiles. Who's familiar with SecComp profiles? So these are a tool for being able to control syscalls. So you can tell a Docker container that it can only do these syscalls, and then if it tries to do one, even if it's just opening a specific file, then it will fail. So right now there are sane defaults. We're trying to make it easier to change those because they're fairly complicated, but we want to monitor what the application is doing and then configure the SecComp based off of that, and then hopefully not cause a lot of issues. It's critical to the least privileged model. So we can't get there with Linux capabilities, but we can with SecComp. So you can control any syscall. And that's a massive improvement. Probably, I don't think massive would fit. So, is anyone confused? Anyone have any questions? You don't get to ask questions. All right, so services, we'll dig into this a little bit. So it identifies pods based off of label selectors. It can be any label that you want. However, you should be careful, because if your scope for that service is multiple different applications and you say tier front end, then you're going to be fronting all of those applications that have tier front end. And that could get pretty confusing. And probably really annoying for your users. So services pass requests internally. So internal to internal communication, and it does something so that it doesn't have to make another stop. It just changes the entries for your DNS inside the node. So instead of routing it to a service, an actual physical thing, it just routes it directly to all of the endpoints that are listed on that node. And it's different than routes because services are only internal, routes are external to internal. And you can have a service that is external, so you can point to like your mainframe if you have any of those, sad face. Then you can point to your mainframe as a service. And then so what happens with the route to service communication is the route is constantly reconfigured with the different endpoints that a service has on it. So your route will not pass then to a service, it will just pass directly to the instances that are running. And this is kind of a diagram that I took from OpenShift. OpenShift has an awesome blog and lots of really nice pictures that you can show execs or whoever needs to see them. So this is the service at the top, it's called web, and then there's port 8080 that's sitting on both of those containers. And there's a replication controller maintaining the number of instances. So here's an application that you can't really read, unfortunately. So up here is the route. This is actually OpenShift. This is what the OpenShift GUI looks like. So the route is application 0, which is the application name, and then presentation is the namespace. Naming is hard. Namespaces in Kubernetes projects and OpenShift are the same thing. So the service is application 0, and the pod, there's one pod right there. So we got one route, one service, and one application. And here's kind of the description. All the descriptions are in YAML or JSON. But it shows that our host is what we're pointing at, the application 0 presentation, there's the route, and then the service that we're pointing at is application 0. You can weight these so you can deploy different versions. If you say 50-50, I want to point it at 2 different services. So if you have some instance that is your beta testing, you can spin that up and send 10% of your traffic there. And this is the service description. It's selected on deployment config, application 0. So that's going to be very specific. No other application should have that, so you're never going to get conflicts of you pointing at multiple different applications. And this is the pod description. And here you can see that there is actually the deployment config, application 0. And a whole bunch of other labels. And so let's change it to tier front end. So our service is now pointing at tier front end. And we have the same route, and we have the service is the same. They both say application 0. But this one up here says application 0 for the application name, and application 1 for the application name. And they both have one pod. Whoops. So we have one route, one service pointing at 2 different applications. So this is some of the complexity you can come into if you have, random labels that are pretty generic, like tier being front end. And so you can see up here we have, maybe you can see Wildfly and Node. So we're converting our old, Wildfly application over to Node. So here's the pod definition again, and that's the tier front end. And we have changed it now to the app name is application 0-beta to kind of show that we could also do a beta test. So now you have your same Wildfly 8 application, and some of the traffic will go here and get the beta version. All right, so that was services. Anybody have any questions on services? All right. So image streams are an abstraction around images for particularly containers, but technically it could be anything in the future. So this picture, also again from OpenShift's blog. So it shows that right here you could have in this, so this is representing a Python image stream, and in this internal is pointing to the OpenShift internal registry. And so it can point there. You can also have other image streams. So latest is actually just pointing at 3.6. And then external registries, so 3.6 and 3.5 are both pointing at Docker Hub. So you can have this one abstraction that can abstract you away from all of the different registries you might have. And inside of a large enterprise may have several different registries, even for different environments. And you can use one image stream to pull them in from different environments and push them into a new environment. And when you push an image into an image stream, very similar to an image in a repository, it will trigger events. So you can say, hey, when this is updated, I want it to automatically deploy, or I want it to call a Jenkins job and start running the tests. And so you can automate your entire pipeline. So inside of the image streams, let's point out some quick metadata that it contains. It contains all the commands that were used to create the images. It lists the entry points, all the environment variables that were used to create the image. I believe that excludes the secrets. It includes all of the layers, so it'll list every single layer, just like if you did a Docker images command. It'll list all the labels that are attached to each image, and it'll list all the ports that are expected to be open on each image. And this is kind of a quick diagram of it. But you see, this is the image stream, and you can deploy version 3 or version 18 into whatever environment you want. So you can deploy, so if you deploy version 18, things don't go well, you can just redeploy version 17. And it keeps a history inside of the image stream for each image name. So that's fun. This is so when I searched cat and operator, this is what I got. I'd say it's the gold mine. So CoreOS, who here knows who CoreOS is? A few people. So CoreOS created something in December called operators, and it took me a while to really understand them. I thought they were like magical creatures. I didn't really understand what they were doing. So I was thinking, oh great, we can package up all of our knowledge and it'll be magic. But really what I want to do is package up all of our knowledge and make it be clear to people what we're trying to do. We don't want to hide, we don't actually want to abstract away everything from the end user. So operators, this is the way they kind of describe them. They represent human operational knowledge in software. So essentially coding your day-to-day operational activities. They use a concept in Kubernetes called third-party resources. So third-party resources all of those things I talked about earlier that are in Kubernetes are first-party resources or controllers. So your daemon sets, that's a controller, your pods are resources. Everything in OpenShift is essentially a third-party resource to Kubernetes. The third-party resources that you can create a controller that controls replication controllers and daemon sets and pods, and then create controllers that control other controllers, and they get a little complicated in there. So it's a controller of controllers and resources is the simplest version of that explanation. It's identical model to the current Kubernetes controllers. It's the OODA loop. They also use the OAA loop, which will be in the next slide, but the OODA loop is observe, orient, decide, analyze, decide, act. So you observe the current state, you orient based off of what it's supposed to be, you decide if you need to act, and then you act on that decision. They're sadly not supported in OpenShift yet. We're working on getting that into so it's alpha in Kubernetes, so we're working on getting all the things on the checklist of the issue in GitHub, cleared out. We're actually dedicating a person to doing this so that we can get these into OpenShift once they're approved in Kubernetes. And so you deploy these into Kubernetes. There's actually companies who are operating their Kubernetes cluster with operators deployed in their Kubernetes clusters. So they scale up their Kubernetes cluster with the operator running in their Kubernetes cluster. Yeah, it's confusing. It seems dangerous. They're also working on being able to bootstrap so that they can spin up a single node and then have that start to, self-replicate its cluster. So all the interactions occur through the new controller that's been created, that operator. So does anybody here know what Prometheus is? Prometheus? It's part of the Cloud Native Computing Foundation now. I started on a lot of these really early. So I started on this like the first month it was released. It's an awesome monitoring tool. But you can use your regular commands where these would normally be kube control git pods, and you can treat them just like a first-class citizen in Kubernetes. So it's an abstraction around the Kubernetes primitives because users just want to use a MySQL cluster. They don't want to have to understand how it all works, and they don't want to have to wait on someone to fix it for them. Also, admins don't want to have to go out and do all of the work across every cluster they have. It'd be much easier just to say, I need to update my operations sequence and update it across all of your clusters at once. So there's some complex tasks that can be performed using these, and that's things like rotating your credentials or certs, upgrading versions. So upgrading database versions is awfully annoying, often annoying because they always have some sort of special sequence of events that they have to have occur. So being able to program those in and say, hey, when we're going from 3.5 to 3.6, do these things. And then you can also schedule your backups and have them restored. So this is what CoreOS has for etcd. You see that you have the observe, analyze, act flow. And you have cluster A has 2 running pods. You have A0 and A01. And the first one is at version 3.0.9. The other one's at 3.1.0. But you actually need 3 instances, and they should all be at 3.1.0. So we obviously have a problem. So it will go ahead and decide that it needs to recover one member, then back up the cluster because it's about to do an upgrade, and then do an upgrade to 3.1.0. And that's all just done automatically. I'm a little cautious in this area because I think that someone needs to be aware that these things are happening and be ready to respond. Because one of the worst things you can do is have these types of complex actions taken in your environment and not know what just happened. So surfacing this information with observability tools is really important. So, am I losing anyone yet? I think I spent like 10 minutes on the plane watching this. One last thing. So, cat memes are always a hit. All right, so deployment pipelines, I believe, have fallen behind. Jenkins is like a decade old, and they've only just finally updated it to be something reasonable. So when we started looking, I work at DST just down the road, but when we started looking for a solution, I don't want to keep using Jenkins necessarily. So we tried to find some other solution. There's even one that was released recently by Yahoo. And Yahoo was, I'm sure everybody else I'm saying, hey, there was a CI/CD thing released by Yahoo, and everybody said, wow, they're still a company? Probably. Sorry if you work there. But I was like, okay, that's, whatever. That's ridiculous. It's called Screwdriver. It's actually really cool. I suggest taking a look at it. It's a little bit too early for production, but it was the closest thing I could find that did both CI and CD. It wasn't pretty limited. But anyway, we're stuck with Jenkins for a while. So let's make it nice. So we created a little bit of an abstraction around pipelines and the deployment stuff for OpenShift, because we feel that those are a little bit more of a commodity and we'll probably change them over time. And we want a common configuration that we can take with all of our different teams that declares what they want their environments to look like, and keep that in their repo with their code. And so we looked at all the different solutions and tried, so this was the hardest part, was coming up with what that document looks like and what the names are and what the actual abstractions are that we want. And we initially we're starting with a whittled down version to avoid any adverse issues as we move forward. But we decided we wanted to have stages, and then inside of stages we would have steps, and we would have applications as a high-level construct. We also believe we'll have documents and other types of things that we'll want pipelines for. We'll have a pipeline template. So at my company at least, we have like 500 apps, and we come from a company that used to buy companies to sell them. And so we're finally starting to integrate all of them and act more like an operating company. And so to introduce any kind of change into all of those pipelines takes a lot of effort. And so any type of new scanning tool or anything that needs to be implemented is a monumental effort that will take years. So we're trying to short circuit that and get everybody into this system. And we'll have a pipeline template which will allow us to inject some controls and guardrails and any type of testing that we need to do. And then that will produce a pipeline config. So here's just a somewhat generic YAML document. The kind is application. It's going to be hard to see. Kind is application. It includes the template here, and it comes from our approved template, so it's like Tomcat 8. In real life, these names are much longer. You can have your notifications set up. You have all of the dependencies that you're going to need for the service type dependencies, not your libraries that you're pulling in. And so these will decide your network connections. And then you'll have your different stages. So you'll have a build stage. That action will be build. You'll have your base image version. You'll have a dev stage as well, where you'll probably deploy it. And in each one of these stages, we have approvers. So you have to approve to get into the stage and then out of the stage. So when it goes to QA, so if someone approves in a dev, it doesn't wipe somebody out in QA. And that way, so there's some sort of manual step of saying, hey, I'm ready to take on this new version. And then a manual step of saying, this one is now approved to move on. And then we layer on the pipeline template. And the pipeline template has some particular things that we mandate and some other things that are optional. And then that kind of combines to create the pipeline config file. And then that pipeline config file is what we use to track our entire environment so that we understand what the environment is expected to be, so that when we orient, this is what we orient to based on what we observe. This allows, so audit, compliance, and security they really like this because it allows them to see what the environment is expected to be and what it actually is. And so we can see when things might be occurring that shouldn't be. And then we have another document that we produce out of these, which is the deployment config. So it takes the same documents and creates a new document. The deployment config, this is literally the OpenShift deployment config. So we can produce that out of the same documentation. And then this will allow us that if we ever wanted to move to some other system, we can just rewrite the microservices that translate these to translate something different. So this abstracts away the audit and compliance and keeps all the records in one place. So if anybody needs to see what happened or what was changed, they can go, they get the data from one place. So the approvals are added dynamically. So if that file changes, so say particularly like connections change, we probably want security to review that and make sure that those connections are okay. So if you open up a connection, you want it to, be open to the internet, and that's probably going to get reviewed by someone. So we'll add in someone from the network side of security. So the tabs versus spaces argument is gone. We just, you get all these documents that say this is how you need to format, and you spend months with a lot of architects hassling over how are we going to format Java or how are we going to format Golang. Well, we just do it for you. So we'll just format it as it comes in, and that's what you get. You can have whatever you want in your IDE. And same with semicolons, depending on what language you're in. So one of the big pushes for getting this out there is to be able to introduce security checks into all of our pipelines. We're a financial services and healthcare company, so we have like every regulation that's ever been created applies to us. So it was very important that we be able to inject any type of security change or any recommendation that's come down into all of our systems as quickly as possible. So this allows us to inject, if we are using white hat or Veracode, we can switch and nobody else knows, nobody else is affected. We can introduce Gauntlet or something, and the application teams don't need to be concerned with it. They will get notified early and often, and they will get feedback on how to fix what's broken. So we won't just say, hey, your thing broke, close your merge request. We use GitLab, so it's merge request. Close your merge request, go away. We'll provide feedback inside of the merge request where people are actually doing work. And so, test all the things so we can inject all the tests. It allows security to be more nimble by being able to make those choices as new things come out, to be able to migrate to them quickly, or business decisions. So say vendor's getting expensive, it's really easy for us to say, hey, we can move, so cut us a deal. We also have common artifact repositories. So does anybody know what I mean when I say left pad? Left pad, yeah, all right. So left pad is what broke the internet a year ago. I don't remember when, maybe a year ago, where the guy pulled his package from NPM and basically everybody broke for 4 lines of code or something. So for some reason I thought that people all controlled their dependencies internally, but it's really important. If you have a dependency that you pull from someone else, pull it into your enterprise or your company, no matter how big or small, and store it locally. We avoided one of those when Chef pulled one from Ruby Gems. I went and got it off of one of our build servers and redeployed it to our internal Ruby Gems. It also allows you to restrict dependencies. So if you know that there are vulnerabilities in dependencies, you can prevent anyone from pulling those down in the first place. And then you can notify people if a security vulnerability is revealed in one of the packages that they have, where it was not known at the time, but now we've discovered it. Now they can get a notification, and we can even rebuild it for them. So it also is a standardized, centralized approval system, so people don't have to jump everywhere to approve everything. And we're now making our application secure by default, so they get all of their checks, regardless. So there's no option anymore of having security or not. There's no more of I just need this box pulled in so that I can have access to prod, and then it never gets patched, and everybody forgets about it, and you end up with 10 applications running on it because it's the only server you can touch and prod. So there's none of that. All right, that's the end. Anybody have any questions?
I have a question.
Yeah.
I saw on there you have Maven. Do you have a preference on a Maven, Gradle, or artifact repositories like technological tools?
Yeah, so the question's around, do I have any preferences around Maven or Gradle or Artifactory and Nexus? So I've worked with both Artifactory and Nexus. I think both are capable tools. The Artifactory UI was more modern, and the Nexus one was, I think, more capable. Is probably the takeaway I have. You usually have to buy other people's tools to properly secure and do some of these things with Artifactory, whereas Nexus, they're kind of built around security. So that was my analysis of that. We use Artifactory and things like Black Duck over at DST, and then Cerner at Nexus. That's one of the other places I work. And then Maven and Gradle, we try to be somewhat agnostic. It just needs to be supportable. And I've used Gradle with Android development and really liked it. Most of my development time has been in Maven. Does anybody use Golang or program in Golang? Anything's better than that dependency management. I wasted a day this week trying to get dependencies worked out. But either one, we went with Maven because that's what everybody has right now. And so at some point we may allow the other one, but yeah, Maven's the primary right now. Anybody else have any questions? No? Awesome. Feel free to come up and chat with me later.